Hello everyone. Now in this lecture we will know about how to find the closure of the attribute set. Now first the concept, that one is a normalization and decomposing. That is, normalization is a systematic approach of decomposing the tables to eliminate data redundancy and undesirable characteristics like insertion, updation and deletion anomalies. This is simply the difference, or it may be a difference between the normalization and the decomposition. Normalization is a systematic approach of decomposing tables. For what? To eliminate the data redundancy or the problem related to a table. We can say that, like insertion, updation and deletion anomalies. Now the closure in a DBMS, or the steps to find the closure of an attribute set, the set of all those attributes which can be functionally determined from an attribute set is called as a closure of that attribute set. Set of all those attributes which can be functionally determined from an attribute set is called closure of that attribute set. Closure of an attribute set, that is X, as example X is a set of attribute, is closure is denoted with the set of X plus, right? Steps to find the closure of an attribute set. Following steps are followed to find the closure of an attribute set. Add the attributes contained in the attribute set for which closure is being calculated to the result set. Add the attributes contained in the attribute set for which closure is being calculated to the result set. We need to select the particular attribute, which one is we need to calculate the closure. Step 2, recursively add the attributes to the result set which can be functionally determined. Functionally determined, we will know about the what is meant by the functionally determined from the attribute already contained in the result set. Now we will go with the example and you can easily understood about how to find the closure. Consider the relation, that one is A, B, C, D, E, F, G. That is the one relation with the functional dependency, this relation. Now let us find the closure of some attribute and attribute set. That is simply find the closure of attribute A. That one is simply the single attribute, not a set of attribute. That is the A plus is equal to A, means when we find out the closure of any attribute, that itself that attribute is the closure attribute of that attribute. That's why firstly we mention A here. Now again we verifies A functionally determined BC. That's why we add the BC here, right? A, B, C. A itself closure of attribute of A, that's why A. Now BC, which one is functionally determined from the A, that is the BC. That's why we mention a BC under the closure attribute set using this relation, using this functional dependencies. Now ABC, we have ABC. Now again we verifies with the BC. Yes, we have a BC in a set, in a closure attribute set. Then we BC determines the DE. That's why we add the DE in a third step. That is with the help of this functional dependency, BC with the DE. Now we again verify with the ABCD individually and the combinedly. D determines F. That's why we add the F here. Now again we verifies with the new combination or a new attribute set. That one is a CF. Yes, we have a CF. That's why it determines a G. That's why we add the G here. Okay. Now this one is simply the way to determine the or maybe to find out the closure of attributes. This one is simple, the closure of attributes A, and that is A, B, C, D, E, F, G. Simple. Now the closure of attribute D, that one is itself a D, then D determines F, and again we verify F determines something, no, or it may be a DF determine something, no. That's why only the DF is a closure of attribute of a D. We cannot determine any other attribute using attribute DF containing in the result set, right? Thus the closure of attribute of a D is DF only. Now the closure of attribute set BC, if the attribute set is a BC, then or multiple attribute, then the BC itself of B and C is a closure attribute of that attribute set. Now B, C, D, E, we just to go with the same, that one is B, C, D, B, C, this one is a relation, sorry, it's not showing, okay, copy, we'll just to copy to near this, that one is attribute of a BC. Now the relation, if we check a BC itself a attribute, closure of attribute set of a BC. Now again a BC determines, we verify BC determine DE, that's why we add a DE with the help of this functional dependency. Now BC D determines F, that's why we add the F here. Now BCDEF is the combinedly or individually determine something CF. Yes, we have a CF, that's why it determines a G, and we add the G here, right? If we verify the all BC, then DE, or the consider A, we have not contained A, that's why we cannot mention a BC. B, but we have a BC, then we determine with a DE. Yes, DE is present. Now D, yes, D determines F. Yes, F is present. Then CF, that one is a G. Yes, CF determines a G. Yes, G is present. Now the A, we cannot mention, or BC, we have a BC, right? But we does not have A, that's why we not verify with this functional dependency. And finally we have the closure of attribute set of the BC is the BCDEFG, right? Then this one is simply the closure of attribute. Why we calculate the closure of attribute? Okay, why we calculate the closure of attribute set or the closure of attribute? Because of, in a previous lecture I have already explained about find the, or to check the particular determine whether the decomposition is lossless or lossy. It contains three conditions, right? The last condition, we just do a intersection of a relation, it's a super key. Under the condition 3 we need to check the closure of the attributes. If we go with the condition 3 here, that one is a B, we got the B. Now we need to calculate the closure of attribute B, right? And that one is simply, that's why I just to explain how to calculate the closure of attribute. Because of when we find out the particular decomposition is lossless or the lossy, under it we verifies the three condition. The third condition, it provides some super key, then we need to find out the closure of that super key, or it may be a closure of that attributes, which one is find commonly, or the intersection of the relation got any attribute, then we need to verify or find out the closure of that value. That's why we just to understand the closure, why the closure of attribute is important. Finding the key using the closures. Now again we will know about finding the keys using the closure. Then super key closure result. If the closure result of an attribute set contain all the attribute of a relation, then that attribute set is called as a super key of that relation. If we go with this example, that one is this closure of A, it contains all the attributes of the relation. It contains all the attributes of the relation A, B, C, D, E, F, G, A, B, C, D, E, F, G. Then A is a super key. We can say that if the closure result of an attribute set contained all the attribute of the relation, then that attribute set is called as a super key of that relation. Then A is a super key, we can say that. But we cannot say that BC is a super key because of it does not contain all the attribute, right? Thus, we can say that the closure of a super key is the entire relation schema. Definitely, it's a reverse of that. In the above example, the closure of attribute A is the entire relation schema. Thus, attribute A is a super key for that relation. For this relation, we can say that the A is the super key because of the condition says that all the attribute which one is comes under the closure of the attribute of that attribute, we can say that that attribute is a super key. Here is the all the attributes is available of the relation. That's why A is the super key of this relation. But DF is not, or BC is not a super key. Now that is the definition or the concept related to a super key. Then candidate key, if there exists no subset of an attribute set whose closure contained all attribute of the relation, then that attribute set is called as a candidate key of that relation. If there exists no subset of an attribute set whose closure contains all the attribute of a relation, candidate key, that one is no subset of an attribute set whose closure contains all the attribute of the relation, then that attribute set is called a candidate key of that relation. In the next lecture, we will in detail about how to find out the candidate key, right? Now the simple example in this above example, no subset of attribute A contains all the attribute of the relation. Thus attribute A is also a candidate key for that relation. Okay, that's why it's showing as a super key and a candidate key A as a super key and candidate key itself. Now we will go with the simple problem. That one is practice problem based on the finding a closure of an attribute set. This is simply the relation considering given functional dependency. Now which of the following option is false? Okay, we want to find out these are the closures and which is the false we need to find out. Means we need to find out the closure of these four and we need to verify this one is right or wrong. Now option A, that one is the CF, closure of CF. If we check it with the CF itself come, CF represent C represent G, that's why come G. Then F represent E, or it may be a 1 by 1. That one is a CF represent from the C and F, C represent the G, right, G. Then F represent the, sorry, that one is G, F represent the E, that's why it added E. Now again G represent the A, G represent the A, it added the A, right? I think it's have a problem. A, C, F, G, G, F added E, then G added A, but it removed the G, it's look like this, right? Then again AF added the D, AF added the D, and finally we got the A, C, D, E, F, G. Right? A, C, D, E, F, G. This one is the right one. Okay, this one is first option. This given closure of a CF is true. We want to find out the false one. This one is a true. Now BG, 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 then closure G is A, that's why I add A. Now AB, which one is represents CD, that's why I added CD, and then AB, CD, G, AB, CD, G, that's why BG closure is also true, right? This one is correctly given, this one is also correctly given. Now we will verify C. Same thing, C, AF, AF, AF represent D, that's why I added D. Now the F represent E, that's why I added E. AD, EF, AD, EF, this one is a wrong, right? This closure of AF is a wrong. This one is not correctly given. Now the same thing as with the AB, it's a A, B, C, D, G, A, B, C, D, G, right? It mentioned with the F, that's why this one is also wrong. It's not correctly given. This one is also not correctly given. Means we can say that option C and D are correct. Option C and D are correct because of we want to find out the false one, wrong one, right? That's why C and D. If we mention a true one, then these two, A and B. That means that one is simply the example of how to find out the closure, right? It's a explanation about how to find out the closure. Which one is we need to find out the closure under the when we verifies the particular decomposition is lossy or lossless. Okay, you can refer the previous video which contains how to find out the given decomposition is lossy or lossless. Thank you.